You want to identify all the horizontal and oblique asymptotes for this rational function. R of x is 2x squared minus 3x plus 1 over x minus 2. Now, 2x squared minus 3x plus 1, is that factorable? We can try, and we can see if it factors. There's not many options, really. 2x squared here, 1 here, negative 3x there. What do I get? 2x times x. Looks like minus 1 actually will work. Negative 1 times 2x is negative 2x. Negative 1 times x is negative 1x. So the top is 2x minus 1 times x minus 1. That certainly doesn't have to happen. And downstairs I have x minus 2. So in terms of our vertical asymptotes, the x minus 2 downstairs does not cancel out. So we know regarding the domain of the function r of x, x minus 2 cannot be 0. So that's going to help us out with our vertical asymptote. Our vertical asymptote will be when x minus 2 is 0 or when x is 2. So we can look at that and see if that's the case. Now, what about horizontal or oblique asymptotes? So we have r of x equals 2x squared minus 3x plus 1 over x minus 2 equals 2x minus 1 times x minus 1 over x minus 2. Now, we look at the degree of the top is 2, the degree of the bottom is 1. So if that's the case, there is no horizontal asymptote. What has to happen for there to be a horizontal asymptote? For a asymptote, for a rational function. The degree of the top and the bottom have to be the same, or the degree of the bottom has to be larger. But in this case, the degree of the top is larger, but if it's larger by 1, we will have an oblique asymptote. The degree of the numerator is 1 larger than the degree of the denominator. When that happens, therefore, we have an oblique asymptote. Now, how do I find that? Well, I will do long division first. So again, we have r of x is 2x squared minus 3x plus 1 over x minus 2. I'm going to take long division, x minus 2 into 2x squared minus 3x plus 1. 2x squared divided by x is 2x. Multiply 2x times x, 2x squared. 2x times negative 2 is negative 4x, and then subtract. Be careful, this is where people make mistakes. 2x squared minus 2x squared is 0. Negative 3x minus negative 4x is negative 3x plus 4x, which is just 1x. Plus 1. 1x divided by 1x is 1. 1 times x is 1x. 1 times negative 2 is negative 2, and subtract. And what do we get? 1x minus 1x is 0. 1 minus negative 2 is 1 plus 2 is 3. So you add the remainder, 3 over x minus 2. If that is the case, that is what r of x equals. So r of x is the same as 2x plus 1 plus 3 over x minus 2. And let's think about this. As x gets really large, like a billion, 3 over a billion minus 2, if there's 3 cookies for a billion minus 2 people, everybody gets basically 0. So the oblique asymptote is y equals 2x plus 1. So the quotient part, ignoring the remainder part. Now, I also could have done this using synthetic division, which is certainly simpler. Doesn't always work. We find the oblique asymptote if the degree of the top is 1 more than the degree of the bottom. This time, the bottom was simple enough for us. It was just a ax plus b type of polynomial, or even better yet, an x minus c type of polynomial. So this is a special case where synthetic division would have worked. So it's x minus 2, put the 2 on the outside, 2x squared minus 3x plus 1. The 2 drops, 2 times 2 is 4, 4 minus 3 is 1, 2 times 1 is 2, 1 plus 2 is 3. Now what does this mean? This means 2x plus 1 with remainder 3. Of course, 3 goes over the divisor, so we get r of x is 2x plus 1 plus 3 over x minus 2. Just a slightly simpler strategy than long division, so our oblique asymptote should be y equals 2x plus 1. So let's take a look at that. We'll go to Desmos. We'll see it and try to identify the slant asymptote. So let's take a look at that. Here we go. So the equation is r of x equals upstairs 2x squared minus 3x plus 1 divided by x minus 2. And let's go back to our home screen, our home graph. Kind of hard to see, but I'm going to draw in my slant asymptote now, which is y equals 2x plus 1. And can you believe that? Let me zoom it out a little bit, and we can feel even better about that. So what this is saying is as x gets very, very large, the graph gets very, very close to 2x plus 1. It's almost a straight line. It's almost a straight line. It's only when x isn't very large that it deviates much from 2x plus 1. But that really shouldn't surprise us, right? Because what did we say? We said the function can be written as 2x plus 1 plus 3 over x minus 2. And if x is a very large number, 3 over a large number minus 2 is basically 0. So that's what the function will be when we deviate far from 2. Close to 2, it's going to be crazy, but away from 2, the graph is going to look an awful lot like y equals 2x plus 1.